Bonjour.
That's French for hello. Okay, so we're going to talk about empirical and molecular formulas today. Hashtag YOLO. Right. So let's first talk about what an empirical and a molecular formula is. So starting with molecular formula.
hmm
Now, Ms. Negarasa, do you remember what a molecular formula is?
So, a molecular formula is the actual formula. And you may remember that when we say molecule, we're talking about a covalent compound. So, this word should look familiar to you.
Okay. Yeah, molecular compounds, covalent compounds. Great. So the molecular formula is the actual formula. Then there's this other thing called the empirical formula. Write this whole thing out here. Now, empirical formulas are slightly different just by definition. These are the lowest whole number ratio formulas. They'll make more sense in a second. So let's just write that. We got lowest whole number ratio formula. And by the way, that's a really weird U. By the way, molecular formula and empirical formula can be the same thing sometimes,
Yeah.
But not all the time. So it's kind of like one of those rectangle is not a square, but a square is a rectangle. Anyways, okay, let's go with some examples here.
Okay. Well, let's talk about ionic compounds first.
Okay, you're the boss.
The ionic compounds, you know how many you have of each in a compound based
Right.
on the oxidation numbers because they have to balance out to zero. So your empirical and your molecular formula are the same thing always for an ionic compound.
So empirical and molecular formula is the same in ionic compounds?
Yes.
Ionic compounds. So that's a very, very important concept there.
Yeah.
We want to make sure we don't forget. I almost forgot it, so you don't forget it. Okay, so can I do some examples now?
Yes.
Okay, we'll leave that up there for a second. But let's talk about, a molecular formula such as C2H4. Now, if I have to decide if this is an empirical or molecular formula, I have to first look at the subscripts and see, is that the lowest whole number ratio form?
No.
No, it's definitely not. So this is a molecular formula. All right. And how did you know that it was not in the lowest whole number ratio?
You can simplify that. So 4 and 2 can both be divided by 2.
Oh, so if I divide both of those by 2, I get just, oops, that's not going to be CH2. So I divided carbon 2 by 2, and that's 1. 4 hydrogens divided by 2 is 2 hydrogens. Now that's the simple whole number ratio, right?
Yes.
1 to 2. I can't simplify that anymore.
No.
So this would be an empirical formula. And as it turns out, CH2 is the empirical formula for C2H4,
right?
The molecular formula. What other molecular formulas could I come up with that have the empirical formula CH2?
Well, you could do C3H6.
Okay, C3H6 could be another one. C3H6, yeah. 3 times 3, right. Okay.
C3H6.
See, even we have to think for a second. So if we multiply it by 4, then that would be C4H8.
Yep.
C5H10. I could go on and on and on.
Yep.
So those are all molecular formulas that have the empirical formula CH2. Awesome. Well, here's something else we want to talk about. How to figure out a molecular formula if we are looking at its mass and then the formula for its empirical formula. This is going to make a lot more sense if I just write it down. So let's say we have an empirical formula of NH2. And let's say I don't know what the mass of this is. What could that be? And I want to know what is the molecular formula of NH2 if the molecular mass, I'll write molecular up here, is 32.046 grams per mole. Okay, so there's two things we have to figure out here. So if I have an empirical formula of NH2 and I have a molecular formula mass of 32.046, yep, how do I figure this out? Where do I start?
Well, you can figure out how many times bigger the molecular mass is than the empirical molar mass.
Okay, so how do I find the empirical formulas?
So we got to calculate molar mass.
Molar mass again. Look at that video if you don't have if you have some issues with it. So 1 nitrogen plus 2 hydrogens, and we kind of done the math for you already. That is going to end up being 16.023 grams per mole. And again, that's just 1 nitrogen and 2 hydrogens.
And that looks, your molecular mass looks 2 times bigger.
Okay, so this mass compared to this mass, the molecular mass you said looked 2 times bigger?
Yep.
2 times bigger molecular mass. I'm just writing everything out so I don't confuse anything. So what does that mean for the molecular formula?
So your formula would also be 2 times larger. So N2H4. Multiply everything by 2.
Multiply the nitrogen times 2 and the hydrogen times 2. So therefore my molecular formula is N2H4.
Yep.
Awesome. That seemed like a lot, but I think we're okay, right? You
Should
guys
be.
okay? Okay. Adieu.